Welcome to the final part of this tutorial, at least for now. If this is not the final part, it's probably because my tutorial has become a huge success and I've decided to add computer control players as well. Either way, let's finish implementing the threefold repetition rule. The strategy we'll use is to associate each state with a specific string. The idea is that two states will have the same string if and only if they are considered equal. This way, we can store the strings for all states encountered during a game. And if the same string shows up 3 times, then we have threefold repetition. Let's take a closer look at the format of these strings. They consist of 4 parts. The first part is the piece placement data. It encodes the position, color, and type of all pieces on the board. The second part encodes the current player. The third part encodes the castling rights for both players. And the fourth and final part encodes the so-called En Passant target square. This part is only included if the current player can actually capture En Passant. If these strings look familiar, it's because they are essentially fence strings, but tailored specifically to our purposes. I will cover each part in detail when we write the code. We begin by creating a new class called stateString. The purpose of this class is to build the string for a given state. We start by adding a string builder variable. The constructor should take the current player and the board. In the body, we'll add each part to the string separated by spaces. Let me outline it for you, and then we'll write a method for each part. First, we'll add the piece placement data. Then a space. Followed by the current player. Another space. The castling rights for both players. A space. And finally, the En Passant data. The piece placement part will be exactly the same as in a fence string. Let's start by adding a helper method called pieceChar. It takes a piece and returns a representative character for it. We use the letter P for pawns. N for knights. R for rooks. B for bishops. Q for queens. And K for kings. Finally, we'll add a dummy case to get rid of warnings. We'll use uppercase letters for white pieces and lowercase letters for black pieces. So if the piece is white, will return the character in uppercase. Otherwise, we return it as is. Next, we can write a method which adds one row of piece placement data. It takes the board and the row to add. Each piece will be encoded using its representative character, but empty squares are encoded as integers. For example, if there are 2 consecutive empty squares, they would be encoded as the digit 2. Here is a concrete example of a row encoding. First, we need a counter for the number of consecutive empty squares. And then we can loop through the columns. If the current position is empty, we increment empty and continue immediately to the next position. If we get past the continue, we have encountered a piece. Now we must first check if empty is greater than 0. If so, we append the number of empty squares and reset the counter. And then we can append the representative character for the piece. Outside the loop, we must check if there are any empty positions at the end of the row. If that's the case, we'll add them as well. With this method, it's easy to add the entire piece placement part of the string. We simply loop over all rows from top to bottom. And add them to the string. And we want each row to be separated by a slash. In the constructor, we can now replace the first comment with a call to add piece placement. Next, we'll add information about the current player to the string. If it's white's turn, we'll add a W and if it's black's turn, we'll add a B. Back in the constructor, we'll replace this comment with a call to our method. Next, we have castling rights. Here, we check kingside and queenside casting rights for both players. If neither player has any casting rights, we simply add a dash to the string and return immediately. Otherwise, if white can castle kingside, we add an uppercase K. If white can castle queenside, we add an uppercase Q. If black can castle kingside, we add a lowercase k. And if black can castle queenside, we add a lowercase q. Great. Now we can call this method from the constructor. Now all that's left is the en passant information. If the current player cannot capture en passant, we just add a dash and return immediately. Otherwise, we get the opponent's pawn skip position, also known as the en passant target square. We have to add this position to the string now. In a fin string, it is stored in algebraic notation, and we'll do the same. You can see how it works here. We can convert from our row and column convention to a rank and a file like this. Finally, we'll add it to the string. Now the constructor will add all the necessary information to the string builder. We just need to provide access to the final string. For that, I'll override toString. Here, we return the string we've built. Finally, we can implement the threefold repetition rule. Let's open the GameState class. Here, we'll store the string for the current state and we'll add a dictionary called state history. The key is a string and the value is an integer. State history will keep track of how many times a given state has occurred. Every time a move is made, we'll create a string for the resulting state and increment the corresponding entry in this dictionary. Okay, in the constructor, we'll create the state string for the initial state. And store it in state history with a count of 1. Next, let's write a method called updateStateString. We'll call this method after each move. First, it updates the string for the state. And then it checks if it's a string we haven't seen before. If so, we add it to state history with a count of 1. Otherwise, if we have seen the string before, we increment its count. UpdateStateString must be called after each move before we check if the game is over. Oh, and if a capture was made or a pawn was moved, then we can never encounter an earlier state again. So in this case, we can actually clear the state history. The last method we need checks for threefold repetition. It simply returns whether the current state string has been encountered 3 times or not. If it has, we know that 3 equivalent states have occurred. So in check for game over, we'll add one final case. If threefold repetition is detected, we end the game by setting result to a draw with the threefold repetition reason. And that's it. Let's check it out. In this game, the state on screen has just occurred for the first time. Now, if I move some pieces back and forth, the game ends the 3rd time the state is encountered. Congratulations on making it to the end of my C# chess tutorial. We have now built this pretty cool game featuring special moves and tricky rules. Of course, there are still many improvements and features we could add to this project. But I hope you now have a solid foundation for creating exactly the game you want. It has been a huge amount of work putting these tutorials together for you. So if you've enjoyed them, then please consider subscribing to my channel and supporting me on Patreon. The more support I can get, the more time I can devote to future videos. Thank you for watching.